So let's put it into practice. Okay? By the way, this is a technique that I find confusing at first, and it's one that you just need to see we got to work a lot of examples. The more examples you work, the easier it gets very quickly. Okay? But I remember when I first learned this, I was feeling a little shaky right now. Okay? Let's go ahead and try this. We're given this curve. X squared plus y squared equals 25, right? This was the function from the previous side. On the previous page, how did we find its derivative? By solving for it explicitly first, and then taking the derivative of each of those two functions. Here we're going to find the derivative implicitly. So this is the steps that I want you to write out. Do write this first step out, folks. People try not to write this first step. They make all sorts of mistakes. So I've said, okay, fine. I need you to write this out, so I will dock you if you don't. Okay? What I'm about to do is take the derivative of both sides of the equation. Okay? Folks, what did I do between the question and this first line? What did I do?
Stated you're going to take the derivative of each side.
Right. I've just written out that I'm going to take the derivative of both sides of the equation. Everyone see that? Okay. So now let's go ahead and do so. Okay. I'm going to go ahead and input a chain rule where it doesn't necessarily belong. Okay. For this first piece right here. What is the derivative of x squared when taken with respect to x? What's the answer? 2x. Okay? The expression inside of the squared function is no more complicated than just an x, so I don't need a chain rule, right? But I'm going to go ahead and write it out anyway, just so you can see what's happening here. Okay? So here we go. The derivative of the derivative of x squared would be 2x times the derivative of what was inside the x squared function. But what was inside the x squared function there? Just an x. Okay? Let me write it like this. This might be more clear. Of course, what is dx, everyone? 1. So it doesn't make a difference whether I write it or not, right? Which is why we usually don't write it. Okay? Plus, what's the derivative of something squared? By the chain rule, it would be 2 times that something times the derivative of the expression that's inside there. Maybe this time through I'll try and do this similarly. So let me write ddx of the stuff that was inside the squared function. Okay? Of course, what's the derivative of the expression on the right-hand side? 0, because we're taking the derivative of a constant. Okay, let's clean this up. This gives us 2x times 1. Where's that times 1 coming from? What do you say, Max? Where'd that times 1 come from? Just line it up, 2x, and then where'd that 1 come from?
In front of like the derivative.
Yeah, what's the derivative of x?
1.
1. Good. Okay. Plus 2y, and then I'm just going to leave this as dy dx. I don't know how to take y's derivative, but we'll call it dy dx. We don't know how to take its derivative, but we know its derivative exists. Okay? And we get equals 0. This part's really important, folks. What did I ask you to find in this problem? dy dx, right? Okay, give the smart aleck answer to a math question. Where's dy dx? There it is, right? Remember, you guys probably seen they make memes of that, right? Find x, and so he points to it and says, there's x, right? But that's literally what we're doing here. I'm asking you to find dy dx. We implicitly differentiated both sides of this equation, and we've got a dy dx expression. Now what should I do with that expression? I should solve for it. Okay? So this gives me 2x plus 2y dy dx equals 0. So that gives me 2y dy dx equals negative 2x. And who am I solving for? Who am I solving for here? dy dx. Okay, Angelo, what am I going to do to solve for dy dx?
Move 2y to the negative 2x side.
Yeah, exactly. Let's divide that 2y over. And that gives us dy dx equals negative 2x over 2y, or dy dx equals negative x over y. Without ever explicitly solving for y, we still took the derivative of this function. Okay? Let's go ahead and find an equation to the line tangent to the curve. Well, let me show up. Let me make sure there's no questions on this. Okay? And there very well may be. You're probably not feeling comfortable with this yet because I've only done one example, and this takes about 10 examples to feel comfortable with. Okay? But the idea is we were asked to find the derivative of this function. So I simply said take the derivative of both, we were asked to find the derivative of this equation, right, with respect to x. So what did I do? I took the derivative of both sides of this equation. Okay, everybody, what did I do? What did I do for my first step?
The derivative of both sides.
Took the derivative of both sides. This is a new step. You hadn't done this before. Everybody, what did I do to both sides? Took the derivative. Did I write dy dx? What did I write? d dx, which is take the derivative of what's inside the brackets, or what's inside the parentheses. Okay. Then here I took the derivative of the first term, which was 2x, and if I wanted to I could put dx dx, but of course what is dx dx? It's 1. But over here, when I take the derivative of y squared, it is 2y times dy dx by the chain rule. When you do this procedure, you will end up with an equation involving the thing you're trying to find. So in finding the derivative, you have to solve an equation, which we've not had to do before. So I simply solve this equation for dy dx. Okay? Folks, it's important that you think of dy dx as a variable. And so we're solving for that variable dy dx. Okay.